Can you see the slide? Can you see the slide, my dear students?
Yes, doctor.
Yeah, preparation of aldehydes and ketones. You can see, right? These are actually we finished already. I hope you remember in the previous lesson. Alcohols, I explained all these things. Okay, I hope you do. You know? Do you remember?
No, doctor. This one I didn't take it.
No. This we did in alcohols, not in this lesson.
Oh yeah. Okay.
Alcohol lesson, I explained all this. Same thing, you remember in the properties of alcohol, primary alcohol on oxidation you get aldehyde, secondary alcohol will give you ketone, all this. Yeah, it was there in that lesson. Okay, so I don't do it all again. Just quickly, I'll just go through it. Okay, so that is primary alcohol CH2OH. If you use weak oxidizing agent like PCC, you get aldehyde. Secondary alcohol, you get ketone. If you use strong oxidizing agent for primary alcohol, do you remember which product you get? If you use strong oxidizing agent here, suppose if you use Jones Street, yes, you will get an acid. So if you use PCC, you get an aldehyde. So that's only difference. See, we did this before. Look, CH2OH will become CHO. Here also CH2OH, CHO. Then secondary alcohol is CHOH. See, this CHOH became CO. Here also CHOH, CO. Okay, this is what we did. Then I hope you remember ozonolysis, right? From alkenes. Alkenes to aldehydes and ketones. Do you remember ozonolysis in chapter 3 we did? Do you remember? Yes, okay, it's there for the next exam. Okay, exam is on Wednesday. I hope you remember. Okay, I will send an email also. Now from alkynes, this also was there in chapter 3. Do you remember adding water in presence of HGSO4 and H2SO4? This also is from chapter 3. That means we just add H2 here, O here. So this part, it will become CH3, this part CHO. But when it comes to unsymmetrical alkyne, addition should be like this. H2 should be at the end. Okay, H2 here, O here. So don't put H2 this side, it's wrong. Okay, you get a ketone. Now you remember Friedel-Crafts acylation. Do you remember this reaction?
Yes, it's in chapter 4.
Yes, chapter 4. Those who studied chapter 4, you find it very easy. That's why I told you organic chemistry, beginning itself, if it's good, it will be very easy because so many equations are repeated. So you will get acetophenone. I don't know whether I explained this or not. Friedel-Crafts benzoylation. Friedel-Crafts benzoylation is exactly similar to Friedel-Crafts acylation. Instead of CS3COCl, we use C6H5COCl. Okay, the reaction is, say, suppose we have one H here, this H and Cl will form HCl. Here also, here H and the Cl give you HCl. Okay, then now, yes, this one I didn't explain. Okay, but you know this one. Structure of carbonyl group. First of all, what is carbonyl group? Carbonyl group is nothing but, come on, what is it? C double bond O group. Okay, this is the carbonyl group. Now, carbonyl group is present in both aldehydes and ketones. Okay, aldehydes and ketones are called carbonyl compounds because of the presence of this C double bond O group. Okay, and you know the hybridization of this carbon. What's the hybridization of this particular carbon? Tell me.
sp2.
sp2. You know why is it sp2?
Yes, because
Why?
you count the lines.
Yes, so count the bonds.
Yes. 1, 2,
Yes,
3.
so here we have one sigma bond, here sigma, here pi. We count only sigma bonds. So total 3 bonds are there. 3 means sp2. sp2 means 3, right? 1 plus 2, it is 3. So here are also 3 sigma bonds. So now, of course, you know, if it is sp2 hybridization, the shape is trigonal planar and bond angle is 120 degree. Okay, you studied this one. We did already in the first lesson. Now next is polarity of CO group. This is something very important. Look here. We did for either, no, either, sorry. Okay, for oh, I rubbed the whole thing. Okay, anyway, O, C, C, this is either. Either is show a polar because oxygen is little negative, here positive is slightly polar. Because oxygen is more electronegative than carbon. But when it comes to aldehydes and ketones, they are much more polar than either. Reason is, of course, oxygen is more electronegative than carbon, but not only that. Look, it has a pi bond. You know the pi bond is a weak bond. So since it is a weak bond, these electrons can easily shift to this oxygen. So the intensity of negative over here is very high, intensity of positive is very high. So they are highly polar. So between two polar molecules, so one molecule is having this positive charge and negative charge. Another molecule also will have same negative and positive. So this negative will attract this positive. So this attraction, so this is here it has two poles. It's called dipole. Here also dipole. Yes, so dipole interaction. Okay, and so the intermolecular force is dipole interaction. It's quite strong. Okay, not like that dipole interaction in ketoaldehyde. Oh, sorry, in either. Okay, so it's stronger. It's quite strong. Now, solubility. These all I hope you know. Lower members are soluble in water. Why? They can form hydrogen bond with water. Only Rahma is there in the class, my dear students. Only Rahma. Others all are sleeping. Now, of course, you know the boiling point of a compound is related to, come on, intermolecular force. Boiling point is related to intermolecular force. Now, in the case of, we are dealing with aldehydes and ketones, okay? So, in alkane, the intermolecular force is very weak, dispersion force or van Waals force. When it comes to alkyl halide, it's weak dipole interaction. When it comes to aldehyde, strong dipole interaction. In the case of ketones, it's stronger because the difference between aldehydes and ketones is aldehyde is having C double bond O H and R. Ketone is C double bond O R R. So this is electron releasing group, here electron releasing group. So this bond is polar, this bond is polar, this bond is polar. So whereas in this case there is only one alkyl group. So this is slightly less polar when compared to ketone. So dipole interaction in ketone is stronger than dipole interaction in aldehyde. But when it comes to alcohol, you know, alcohol has hydrogen bond. Okay, the intermolecular force is strong hydrogen bond. So the boiling point of alcohol is higher than that of ketone. And the acids are having the highest intermolecular force. It's extremely strong hydrogen bond. This part in the next lesson I will explain about the acid. Okay. So this is the order of intermolecular force. Don't forget. Okay. But then when you compare this one, we will go for the comparable molecular mass. Okay. So alkane, then what else? Alkane, alkyl halide, aldehyde, come on, ketone, alcohol, acid. Okay, acid is having highest volume point among them. Okay. Now, next is chemical properties. Okay, look here. Can you read the heading?
Nucleophilic addition reactions of aldehydes.
Yes, nucleophilic addition reaction. We did before some other nucleophilic reaction. What was that? Do you remember?
Substitution.
Yes, substitution. You know the difference between substitution and addition. Substitution means one is coming in, another one is going out. It's one atom or one species, one group is replaced by another group. That is the meaning of substitution. Addition means it's not like that. We are not replacing something, we just add. So here in the case of aldehydes and ketones, that's a specialty I told you. It has a sigma bond and a pi bond. This pi bond can be broken down. So you will break this pi bond, okay? And before that, this is having show a negative charge. This is having slight positive charge, a small negative, small positive, polar. And nucleophiles are electron-rich species, so they are having negative. This is having positive. So actually, what happens is we break this bond, and this positive will take this negative, right? And
Yes.
this positive will take this negative. So what do you get? C, single bond C. O, here, what is coming? Which group is here?
The nucleophile.
Nu. And here, which group?
H.
H. That means we added. We didn't substitute anything. Is it okay? We added. Added what?
A nucleophile and H.
So it's called nucleophilic addition reaction. This is a specialty of aldehydes and ketones. Reason is they have polar CO group. That's the reason. Okay, sigma bond is there, pi bond is there. Now actually this reaction, even though I wrote it in one step, it takes place in two steps. Step number Vahat, you will add. Can you see? This is having slight positive charge. This is having slight negative charge. We are adding a nucleophile. So step number one, the nucleophile is getting attached to this carbon. So this bond will shift completely. So and you know the hybridization of this one is sp2. We did this on the previous slide. So now Nu is going, you will get an intermediate. See, look at the this carbon is bonded to 1, 2, 3, 4 bonds. So what is the hybridization? Yes, hybridization changed from sp2 to sp3. And next step, H3O plus. H3O plus means H2O slash H plus. So next step you will add H plus. This H plus will go there and you get this addition product. That is this product. Is it okay? Okay.
Yes.
And this reaction is catalyzed by H plus. Okay. Now, actually, aldehydes are more reactive than ketones towards nucleophile. See, look, dears. I can just remove this, right? Okay, see, look. The difference between aldehyde and ketone is R. Here it is H. Here R, C double bond O, here also R, okay? This is a ketone, first one is an aldehyde. Look, in the first step, nucleophile should approach this carbon. So this carbon is surrounded by one big bulky person and a small hydrogen. Whereas in this case, it is surrounded by two bulky people.
So steric
yes, steric hindrance. So nucleophile cannot approach this carbon easily because it's surrounded by two bulky group. So ketones, actually one more reason is there, but then it's okay for you. This is enough. Okay, it depends on the intensity of positive. There is something there, but it's okay. So this is easy to understand. Okay, so because of the big groups, ketones are less reactive than aldehydes. So that's what it's given. Aldehydes are more reactive than ketones towards nucleophiles. Okay. Now we are going to do the examples. Actually, even though all new reactions, all of them are so easy, very easy reactions. Okay. Okay. And we ask all these questions in the final exam. Okay. So don't expect expect the same question. I'll change the question, but similar ones. But then you don't have to by heart anything. Don't memorize. Try to understand how I'm going to do the same. Can you see there are two equations given? I'm going to write those two equations again to make you understand. Okay. These are these two same reactions. See, look. In nucleophilic addition reaction, there is a hint. Okay. Always write like this: CH3 C double bond O H plus. You are adding an alcohol HOC2H5. This reaction is catalyzed by dry HCl gas. Just imagine we are adding 1 mole of alcohol to 1 mole of aldehyde, same amount, or 1 aldehyde group and 1 alcohol group. See, the hint is nucleophilic addition reaction, it depends on the intensity of negative and positive. Here it has slight negative, oxygen is more electronegative. Now here carbon is getting slight positive, and in this case oxygen again gets negative, carbon is getting positive. So what happens is this pi bond will, one of the bonds, no, one is sigma, the other one is pi. The pi bond will be broken and the positive part of the alcohol will go to the negative part of the aldehyde. Okay, so what will happen? So this H has positive charge. It will go to where? Which atom?
Oxygen.
Carbon or oxygen? Yes, it goes to oxygen. Similarly, this is having negative. It will go to this one. See, I told you don't memorize anything. It is so easy. Okay, so you will get. Tell me CH3. Tell please.
C
Mm-hmm.
H.
Okay.
And it's attached to OH.
Yeah. OH and then
another H also.
Another H?
No, sorry. Another O.
O, and what is left? Yeah, C2H5. C, yes, very good. Look here, dears. On the same carbon, we have one OH group and OC2H5 group. We call this one, there's a name for it. It's called hemi. You know, hemi means half. You know, hemisphere, you studied hemisphere, no? What is hemisphere?
I don't know, something in geography or something.
Yeah, something in math. Sphere means full sphere. Sphere, no, ball, it's a ball. Hemisphere means half of the ball. Half. This is hemi, half. Okay, anyway, leave it that.
I remember
It's not enough.
hemisphere.
Sorry? Sorry?
I remember it, hemisphere.
Okay. Okay. Anyway, leave that. So now here, so this is the name only acetal, hemiacetal. This is the cause. Now, if you treat this with one more molecule of alcohol, treat this with one more molecule of alcohol, HOC2H5. So here, again, reaction is catalyzed by HCl gas. I'm not going to write. So H and OH form a molecule of H2O. See? So what do you get? Tell me. CH3, CH. Come on.
O.
Yeah. O.
And OC2H5.
Yes, C2H5. Here, straight also. O.
Also C2H5.
Same, no? Same. So that means two OC2H5 groups on the same carbon. It's complete. So this is called acetal. Okay, so this is hemiacetal and this is acetal. So this is the reaction of aldehyde with alcohol in presence of dry HCl gas. So if you use less amount of alcohol, you will get this product. And if you use more amount or excess amount of alcohol, you get acetal. Okay, understood?
Yes.
Did you understand? Okay, so now similar reaction with ketone, show a little difference is there. Look, I'm going to write for ketone one, CH3, C double bond O, CH3. You know this is propanol or acetone. And this alcohol is a dihydric alcohol. We call it as ethylene glycol or simply glycol. Okay, CH2OH, CH2OH. You understood what I'm writing? This is the same alcohol. Okay, so again reaction is taking place in presence of dry HCl gas. Okay, so now what happens is this one is actually easier than the other one. You can remove H2O like this. See, one molecule of H2O is removed straight away. So what do you get? CS3. Come on. C, CS3.
C, and the bond is broken.
O, yes, here also O, and what is left here? CH2, CH2. So this is called ketal. This is acetal. This is called ketal. Here we use ethylene glycol. Since we use ethylene glycol, it's called ethylene glycol ketal. Okay, understand? Go home and after the lecture or today anytime, you just write these equations 2 times so that it will stay there. You will not forget to. Okay. Even though it's not for this exam, you just practice it. Otherwise, you will forget it. And now, next one also is so easy reaction, but it's new reaction for you. Even the same reaction is given in the next lesson also. Organic amine ligates, carboxylic acids. First of all, a reaction with Grignard reagent. Okay, I wrote what Grignard reagents are. They are alkyl magnesium halides or aryl. Aryl means benzene. Okay, benzene magnesium halide. Aryl means always it's not benzene. It need not be benzene. It can be some other aryl group also. But then you study only this one. So they are alkyl magnesium halide or aryl magnesium halide. I gave some examples. CS3MgBr. Instead of CS3, it can be any alkyl group, C2H5, C3H7. Instead of Br, it can be Cl or I or anything. So here, C6H5 MgCl. They are highly reactive compounds and they are versatile compounds because you can make a variety of compounds from Grignard reagents. They are highly reactive species. Now, what is written here? Formaldehyde. That means methanol. Okay, methanol. On treatment with... Sorry?
Spelling mistake. Formaldehyde.
L is missing. Okay, I'll correct it. My dear, you are so nice, so good. Whenever you find something, please tell me, okay? Okay, so you just send a message in the group so that I can correct it. I corrected the other one you said that day, no? When I didn't notice it, okay? Another one sulfur compound. Okay, yes. Okay, so spelling mistake. L is missing, yes. Okay, formaldehyde on treatment with Grignard reagent followed by hydrolysis, you get a primary alcohol. And all other aldehydes give secondary alcohol and ketones give tertiary alcohol. Okay, see, it's very simple. I will explain. One I will explain and the other things you can write. See, first of all, formaldehyde. Do you remember the formula? Question is HCHO. This is formaldehyde or methanol. You treat this with CS3MgBr followed by hydrolysis. Okay, so how to write the format? Okay, look, all are with me, no? H,
yes, sir.
C double bond OH, just like what we did in the previous case, plus CS3MgBr. This reaction is catalyzed by this reaction is taking place in dry ether medium. There should not be any water because Grignard reagents have very high affinity for water and you get some other product. So the reaction will be between Grignard reagent and water. So to avoid that, we use dry ether. There should not be any moisture. Okay. Now the hint is a little little negative and positive. So here it is a slight negative, here positive. Here again, magnesium is metal, so it will get positive charge. Carbon, non-metal, it gets negative charge. So as usual, the normal compound, tell me. What do you get? What do you get?
Here, doctor, the entire CH3 will move or just the C?
CH3, CH3. C means it's H is attached to, this bond will be broken. We
So
break
it will
this.
go to the carbon, to be attached to the carbon.
H, yes, C, here O, and then to this O, who will?
The magnesium, Br.
MgBr. And to CH3, the CH3 will go to C. See? Understood? Just addition.
Yes.
This is nucleophilic addition reaction, all these. H3O plus. Hydrolysis. Next step is hydrolysis. So what will happen here? Here H, H. Okay, so now tell me the products. What are the products? You get CH3, CH2, correct? No, CH3, CH2. What is the other one? OH. Plus the side product is MgOH. This is the reaction. See, I will do this thing in an easy way. Look, H, C, double bond O, H. Or if you want, I can write like this also, okay? Now plus, first step I will add CH3, MgBr. Second step I will add H3O plus. This is in presence of dry ether medium. Now what will happen? See, this part will become, oh, see, when you add HOH, no, this part will become, okay, O will become OH. Now whatever group is here, it will come here. So what's the product? Tell me. CH3, come on. CH3,
CH2, OH.
CH2, OH. Suppose instead of this, I use HC double bond OH. I use say CH3, CH2, CH2, NgBr. Second step H3O plus. Okay. So now tell the product. What will happen here? It will become one H, and this alkyl group, whatever is present, will go.
We'll go to the carbon.
So what's the product? What's the product?
CH3,
CH3,
H2, C,
Yes.
CH2,
H2, OH.
OH.
See, this CH2OH is from the aldehyde group. That from the formaldehyde. This is from the Grignard reagent. So similarly, you can do for acetaldehyde also. Okay. Say CH3, CHO. I'm not going to do in the long way. We'll do it in the short way. You understand how to do in the long way, right? CH3 MgBr. Okay, this is a question. So how to write the answer? CH3 C. Come on.
Double bond O and H.
H. Now first step I add CH3 NgBr. Second step I add H3O plus. Now tell me what will happen here.
One H will go to the oxygen and break the pi bond, and then whatever is the R group will be attached to the carbon.
Okay, so what do you get? CH3,
CH3,
C,
C,
down,
CH3,
3. Straight up, what do you get?
OH,
Straight, what do you get?
H.
H. So that means CH3, CH, OH, CH3, right?
Secondary alcohol.
Secondary alcohol, yes. That's what it's given. Formaldehyde gives primary. If it is a primary alcohol, remember one of the reagents is formaldehyde. Formaldehyde can give only primary alcohol, whereas all other aldehydes give secondary alcohol. So this is a secondary alcohol. Alpha carbon is attached to one carbon here, one carbon here. And ketones give tertiary alcohol. We'll go for a ketone. See. CH3, COCH3 plus which Grignard reagent you want? Say, tell me, CS3. Tell me a Grignard reagent other than CS3 MgBr.
MgI.
Okay, instead of CS3, some other group.
CH3, CH2, CH2.
CH2 MgI. Okay, so now how do we write CH3? C double bond O CH3. First step CH3 CH2 CH2 MgI. Second step H3O plus. Yes, tell me. To this O as
We'll
who
get
will
an
come
H.
H. And what about the other part?
The R group.
The R group will go here. Okay, so the product will be
CH3.
Yeah.
CO. H. Sorry, COH. CH2, CH2, CH3.
CH3, CH2, CH2.
Yes. So it will be CH2, CH2, CH3.
CH3.
Don't write CH3, CH2, CH2. Okay, it should be CH2, CH2, CH3. Valency should be satisfied. Okay, so here CH3. See, look, alpha carbon is attached to how many groups? One here, one here, one here. So this is a tertiary alcohol. So if the product side, if it's a tertiary alcohol, original one is a ketone. If it is a secondary alcohol, original one is an aldehyde other than formaldehyde. Okay. Now these all are there. I just wrote these things like an So I will make copy and okay. So the next one is similar reaction. Addition of hydrogen cyanide. This also is coming under nucleophilic addition reactions. All nucleophilic addition reactions, the hint is little negative, little positive. Okay. See, look. First of all, HCN is highly unstable. This is highly unstable. So it has to be prepared on the spot in the reaction mixture. Actually, instead of adding HCN, we will add NaCN and HCl. We don't use this. Instead, we use these two. So when you add these two will react and you get HCN. The moment HCN is formed, it will react with the aldehyde or a ketone or whatever. Okay. So this is called in situ preparation. In situ means on the spot in the reaction mixture. Okay. Now, as usual, you tell me the product. Come on, this is nucleophilic addition reaction. The hint you know. Tell me, how do you do it? Oxygen has little what charge?
Negative.
Negative. Carbon has
Little positive.
little positive charge. Now H, what the charge?
Will have positive.
Yes, positive. And this carbon will have
Negative.
negative. Okay, so now tell me. Tell me.
So H will go to the oxygen and break the pi bond, and CN will go to the carbon.
Yes, CN will go here, and O will become OH. H done. Its name is cyanohydrin, but name is not very important. Only IUPAC names are important. Now, similarly, another one. Come on. CH3, C double bond O, CH3 plus HCN. Okay. Again, O has little negative. Come on.
C has little positive.
What is this? It's what's going
what
on
happened?
Here. When I breathe, I think the next page is coming. Okay, because I wrote all those things in a proper way on the other slides. Okay, because I need to give you the notes. No, these all scribbled. That's coming. Okay. Yes. Okay. So now here slide negative. Here, sorry. Yeah, correct. Positive. Oh. Okay, this is having slide positive charge, and here slide negative, and here slide positive. Okay, so tell me the product. Come on, please. CS. This much is safe. This much is safe. After that, what is there? Tell me.
H.
H. Then here.
Here it's C.
C. Okay, got it, right? Got it, right?
Yes, doctor.
Okay, so these all come under nucleophilic addition reaction. So you don't need to memorize anything. We just write slide negative and positive, then you add. Okay. Now next, this is next type of reduction. I hope you remember primary alcohol on oxidation, you get aldehyde, right? We did this. Primary alcohol on oxidation, you get aldehyde. Secondary alcohol on oxidation, you get ketone. You remember?
Yes.
You remember? Okay.
Yes.
So now it's opposite. Opposite of this. Aldehyde on reduction, you will get
Primary alcohol.
primary alcohol. Ketone on reduction, you get secondary alcohol. So it's just opposite. Okay. Okay. So now here actually what happens is this bond will break. One of the pi bonds will be break. Reduction means addition of hydrogen. You know that. Okay. H. See what do you get? CH2H. If you break here, come on, tell me. Tell me. One of the so you put H here also. So what do you get? CHOH. See, you don't. If you apply common sense, you don't have to by heart anything. Okay. Okay, and reducing catalyst. Catalyst can be PT, it can be nickel, it can be palladium, it can be LiLH4, it can be NaBH4, anything can be used. Okay. Now, so in short, CHO will become, come on, tell me, CHO will become CH2. Come on, OH. So tell me the product. This CHO will become CH2OH. This CO will become CO will become, what happened? Can you hear
CHOH.
Yes, CHOH. Okay. Yes, so you will get CS3, CH2OH. The other one is CS3, CHOH, CH3. So that is, see, this became CH2OH, this became. Okay, similarly here also, tell me, CHO will become, come on, CHO will become?
CH2OH.
OH. CO will become?
CHOH.
Or CHOH, but we don't show that H there. H is there, okay? H is there on this carbon, so since it is cyclic, we don't show that. Okay, then that's okay. Next is oxidation. See, here, look at this one. Aldehydes can be easily oxidized to corresponding acid. You understand? RCHO will become, or CH3CHO will become CH3COH. CH3CH2CHO will become CH3CH2COH. That means CHO can easily become COH. This process is so easy and it can be easily oxidized when compared to ketones. Oxidation of ketone is difficult, whereas oxidation of aldehyde is very easy. Reason, look over here. This much part remains the same. Correct? So it involves the breaking of just one bond. Which bond? Which bond? CH bond. It involves the cleavage of one bond. So this process is very easy. Whereas if you want to oxidize a ketone, we need to break a lot of bonds. So it's difficult. Okay, so that's what it's written there. Aldehydes can be easily oxidized to corresponding acids. As the oxidation of aldehyde involves the cleavage of only one CH bond, this process is easier than the oxidation of ketones. Oxidizing KMNO4, it's a strong oxidizing agent. Jones reagent is a strong oxidizing agent. Silver oxide is weak. Tollens reagent is a very weak oxidizing agent, very weak oxidizing agent. But even weak oxidizing agents can oxidize aldehydes to Aldehydes to
acids.
acids. Okay, but to oxidize ketone, we need strong oxidizing agent. Look over here. KMNO4. Just a minute. Okay. See, look at this one. Here CHO became COH. Here also CHO, COH. Here CHO, COH. But here in this case, something very important you need to remember. Tolerance reagent means if you treat silver nitrate, it's not the actual method, the actual procedure, but I'm telling you the main thing. If you treat silver nitrate with ammonia solution, you will get this tolerance reagent. This is a complex compound, not a normal compound. Okay, and aldehyde will be converted to acid. The tolerance reagent, in tolerance reagent, Ag X stars Ag plus. Now Ag plus is reduced to silver. You know silver exists as a mirror, silver mirror. You know silver mirror means it's bright in color. You know mirror. What's the Arabic word for mirror, dear?
منظرة.
What is that?
منظرة.
Membra. Okay, so early morning you look into the mirror, right?
Not
Or oh, now you don't go to university, so you don't have to, right? No makeup, nothing.
no need.
You miss all that. Oh my God. Okay, I hope everything will be okay soon. Okay, so now see, I'll show you. This is the one. So using this test, you can distinguish aldehydes from ketones. See, look what is written there. Tolerance test. To get tolerance reagent, I told you treat the silver nitrate with ammonia, you get tolerance reagent. On warming aldehyde with tolerance reagent, silver mirror is obtained. See, aldehyde will be converted to acid. This Ag plus present in the tolerance reagent is converted to silver mirror. You get silver deposits. Ketones do not give this test. Okay, so that means ketones plus tolerance reagent, there is no reaction because tolerance reagent is a weak oxidizing agent. Yeah, it cannot oxidize ketone, but it can oxidize. It can oxidize
aldehydes.
Aldehydes. So this is a test to distinguish aldehydes from
ketones.
Okay, look at this one. Can you see? Can you see? This is the one. See, first take the tolerance reagent, you heat this thing in a water, but actually when you do this thing in the lab, no, we make people, not you, we have another course, Chemistry 223, organic chemistry. It's for bio students. So they do this test in the lab, tolerance test. So it's so easy to, it's so nice to see. It's very bright silver color will be there. It's like a mirror. Okay, so this is silver mirror test, tolerance test. Okay, understood?
Yes, doctor.
Okay, now this is the last part of this lesson. This lesson is over. Now, do you remember I told you last lecture? Can you stay back for at least some people can stay back? Those who don't have, sorry?
It should be okay.
Okay, yes. Otherwise, we won't finish, dear. So we have to do chapter 10 and 11. Though they are easy and small, I need to finish it, no? Okay, I think your final exam is this month only, May. So I don't want to give the lecture till the last moment. Okay, dears. So I'll take the attendance now. Better if you have issue. And now. Or I don't want to waste time. Is it okay? So I know who all are here. Okay, fine. Better not. Okay, there is no time. Okay, fine. Okay. So now here, look. I hope you remember all this. Do you remember IUPAC names we did at the beginning?
Yes.
Okay, the functional group of acid also, you know, C double bond O or COH. This lesson is carboxylic acid lesson. Did I tell you?
Yes, we saw the first slide.
Yeah, yes. Okay, carboxylic carboxylic acids and its derivatives. Now functional group is, all of you know this one, but before I didn't do one particular name. Which name? See, can you see? Yes, carboxylic acid we didn't do. Actually, like I told you about aldehyde also. I wrote in bracket mostly for cyclic compounds. It's not really for cyclic compounds, other compounds also, but that kind of questions will not be asked for you. Okay, so for you, just we use carboxylic acid for cyclic compounds. Okay, other compounds we write oic acid. You know this one, alkanoic acid. There is no gap in between. Okay, between here you can leave space, maafi mushkil, but here you should not leave space. It's a mistake. Okay, it's alkane carboxylic acid. So now the names I hope you know. You remember these names at COH, only one carbon atom. So it's methanoic acid. You know that's right?
Yes.
Okay, so here how many carbon atoms are there total?
2. So ethanoic acid.
Here how many are there?
3, so propanoic acid.
So propanoic. Here, come on, 1, 2, 3, 4, 5. But it has 2 COH groups. So what is the name?
Pentane dioic acid.
Yes.
But doctor, shouldn't we write the positions?
Yeah, that's what I'm telling you, dear. I'm going to tell that. This E is there or not?
It's there because D is not a vowel.
Okay, now the next one, your question. Actually, it's more correct if you don't write 1,5. Even if you write 1,5, it's okay. Okay, because in order to tell oic acid, it has to be at the end. It has to be part of the chain. Even if you don't write 1,5, you know, if you are writing oic acid, it has to be C double bond group this end and this end. Otherwise, it will not be oic acid. It's if once it is a part of the chain, it's oic acid. So that's why. So if you write 1,5, you will, I will not cut your marks. Okay. Final exam, there are questions, writing questions. Okay. The names all you have to write. So many questions you need to write. Okay. I set the paper in such a way that using the keyboard you can write the answers. Okay. So don't worry.
So doctor, since COH can only be on the edges, so it's only di, right? There's no tri or tetra or anything.
No. Try. It's different, my dear. I told you, no, that's not there for. If you want, I can teach you after the lecture. Okay?
No.
Understand that. There are the 3 COH group is there, but the naming is not this way. We use the other one, carboxylic acid. Okay. Yes, dear. Tell.
What if we had double bond?
In the this one, you mean this kind of question?
Yeah.
Okay, it's there. I will explain. Okay.
It should be in instead of ain, right?
Yeah. I'll explain. There is a one question I kept for you for doing that one. Okay. Now look here, my dear students. Benzene ring with COH or C6H5COH. Don't write it as heptanoic acid. Okay. It's not heptanoic. It is benzoic acid. And look, COH. This is a cyclic one. Actually, benzoic acid is the common name, which is taken as the IUPAC name. Benzoic acid common and IUPAC. Now it's proper IUPAC name. I told you, mostly for cyclic compounds, we use carboxylic acid instead of alkanoic acid. So in that case, what is the name here? Benzene carboxylic acid. So this also is cyclic. So tell me the name.
Cyclohexane carboxylic acid.
Yes, so it is also, this is cyclohexane. This one will be
cyclopentane carboxylic acid.
Pentane carboxylic acid. Okay, Do you remember this one? It's orthohydroxybenzoic acid or salicylic acid. We did this. This is the common name. What is its IUPAC name? COH has more preference. It's 1, 2.
So it's 2-hydroxy
benzoic acid or 2-hydroxy
benzene
carboxylic acid. In this name, there are mistakes. What are the mistakes? So you should not leave any gap. Mafi gap here, mafi gap here. Okay? Yeah. So when you write the thing, don't make mistake because I don't want to correct it now. Okay. Now, yes, my dear. Who asked me the question, dear?
Me, doctor.
Who?
Aisha.
Yes, Aisha. Aisha, dear, look here, my dear. Can you try doing this one? COH has more preference, the most preference. So where
This
you put
is
number?
from the beginning, from the one that
Yes.
has the carboxylic acid.
1, 2,
3, 4, 5.
5. Aisha, my dear, can you try? OH will be the suffix or prefix?
Prefix.
Will be the
Yes.
suffix.
Prefix, yes. Now, ENE. This is ENE. It's suffix or prefix?
Suffix.
Suffix, yes. COH, suffix or prefix? Oic acid, suffix or prefix? Suffix, because it has maximum preference, right? Yeah?
Yes.
Yes, Aisha, try. First prefix, then parent, then suffix. Yes.
Should I consider number 2?
Which 2?
No, I mean like I will say 5-hydroxy like this.
Yeah, yes. Tell.
It will be 5-hydroxy.
5-hydroxy, yes.
Bent 3 in.
Bent 3. Oh, 3.
Then in.
ENE, okay.
Should I say also 1 or like?
No. Oic acid, we never tell 1. Aldehyde, we never tell. Yeah, my dear student, good you asked me. See, aldehyde and acid, aldehyde we write Al, don't write 1 Al. Acid we write COH, oic acid, don't write 1 oic acid. Okay, it's obvious it's 1. So we start numbering with that all cases, so you don't have to put 1. Okay, yes, now tell dear.
Then oic acid.
Yes, oic acid. I removed something. What is that?
You remove the E.
Yes, I removed
because
the E. You know
O
why?
is a vowel, so it cancels it.
Yes. So remove E. Okay, I didn't do that E. Now it's clear?
Yes, doctor, clear.
Now, these all we didn't do. Acid derivatives. Acid derivatives means they are obtained from acids. Okay. First one I wrote acid itself. RCOH. By mistake, when this thing is coming. RCOOH. Acid chloride means OH is replaced by, come on, my dear students.
CL.
OH is replaced by, in this case, okay. Here OH is replaced by Cl. In this case, OH is replaced by NH. OH is replaced by ester. OR. Look, one more point I want to tell you. Last semester for the final exam, majority of the students made these questions wrong. Do you know what kind of mistakes they made? They wrote, if I write RCOCl, they wrote chloroketone. So it's not chloroketone. Or if I write CS3CONH2, they wrote aminoketone. And if I write CS3C double bond O CS3, they write ethoxyketone. So it is wrong. In order, listen, all of listen, it's very important. In order to be a ketone, C double bond O should be attached to carbon atoms on both sides. Otherwise, it's not a ketone. Ketone means it's like this. This is a ketone. So don't mix this with the other things. Understood what I meant? Here in this case, CO is not attached. CO is attached to carbon here, but it's not attached to carbon here. So it's not a ketone. Similarly, CO is attached to carbon this side. Here it's NH2. So it's not ketone. So they all are acid derivatives. Is it okay? So they are, it's not separate CO and Cl, it's CO, Cl as a whole is one. This is the functional group, not separate, or this is the functional group. Is it clear now?
Yes, doctor.
Okay, so please don't mix it up. Bear this in mind, okay? Don't make mistakes. Okay. Now, it's easy. Actually, there are complicated names for these also, but I removed all the complicated ones, only the simple ones. Acid chloride suffix name, you don't need to know the prefix name also. Suffix is OY, oil chloride. So UPSC name alkane plus oil chloride. So I removed the E. Why I removed the E? Because O is a
Vowel.
vowel. So the name will be alkanoyl chloride. So don't forget C double bond OCl, the name is oil chloride, not chloroketone. So now first one has 2 carbon atoms. Can you tell me the name?
Ethanoyl.
Yes, ethanoyl chloride. Next one, how many carbon atoms are there?
3, so propanoyl.
Yes,
chloride.
yes, propanoyl chloride. Next, it's from benzoic acid. Yes, benzoic acid, so it's benzoyl chloride. Similarly, next one, CONH2. What's the suffix name? Amide. So alkane plus amide is alkanamide. E is replaced. Okay, alkanamide. Alkane plus amide is alkanamide. So now first one is CH3, CONH2. 2 carbon atoms are there. Tell the name.
Ethanamide.
Yes, ethanamide. Okay, not amine, it's amide. Ethanamide. Next one.
Propanamide.
Yes, propanamide. Next one.
Is this benzenamide?
Not benzenamide, my dear. It's from benzoic acid, not benzenoic acid. No, benzoic acid. So it is benzamide. It is benzamide. Okay, yeah, it's very easy, right? Now the name of ester. After finishing ester, I will stop. Okay. Yeah, it's 1 hour for you. Now, ester, the name is alkyl alkanoate. Alkyl alkanoate. In ester, we have C double bond O group. A preparation of ester is there coming in the lesson. At that time, it will be more clear for you. So that's why I didn't write that reaction here. Please look, we have 2 parts. One is O part, the other one is CO part. O part is alkyl part, alkyl, methyl, ethyl, propyl. Alkanoate, methanoate, ethanoate, propanoate. It goes like that. Okay, so split into O part and CO part. Okay, so now first one, OCS3. So what is the name? This is which
Methyl.
part? Methyl.
Ethanoate.
So this is, yes, 2 carbon atoms, no? So it's ethanoate. So when you write first methyl, then ethanoate. So the name is methyl ethanoate. Okay, next one. Come on. O part has how many carbon atoms?
Ethyl.
Yes.
Propanoid.
Ethyl. Yeah. This part has 2 carbon atoms, so it's ethyl. This part has 3 carbon atoms, so it's propanoate. Okay, next one.
Ethyl ethanoate.
Yes, both of them 2 carbon atoms, right? Here 2, here also 2. Okay, here 2, here 2. So it's ethyl ethanoate. Now, next one.
Here, is this benzyl?
No dear, no dear. C6H5 is not benzyl, it's phenyl.
Okay.
Phenyl, okay? So don't forget phenyl. So it will be
Phenyl ethanoate.
yes, phenyl ethanoate. Okay, then.
This is methyl something.
Dear students, tell me the name of this compound, what I wrote there.
Benzoic acid.
Benzoic acid, okay? So can you tell me the salt of benzoic acid will be?
Benzyl?
No dear, benzoate.
Okay.
A salt of ethanoic acid, ethanoate. Propanoic acid, propanoate. Butanoic acid, butanoate. Benzoic acid, benzoate. Okay? So this is same as benzene ring with C double bond O, OCH3. Yes, tell me.
That's methyl benzoate.
Yes, methyl benzoate. Now the last one.
Phenyl benzoate.
Yes, phenyl benzoate.
Doctor, I'm a bit confused between benzyl and phenyl. When is it phenyl? When it has an O?
I will clarify it. Just a minute. Let me see if I have a anything. Okay. See. This benzene ring CH2 group is benzyl group. This is benzyl. Okay. Yeah. Say suppose benzene ring CH2 group. That's why we don't use benzyl group. So this is benzyl chloride. So we don't use the other one is phenyl. Whereas benzene ring with Cl, these are the common names. It's phenyl chloride. Common name, okay? Not diabase name.
So if it's CH2 attached to the benzene ring, it's benzyl. But if it's just the ring, then it's phenyl.
Yes. Okay. Yeah. Now that's it. The remaining things. Tuesday also, you please stay back a little more, so we will be able to finish fast. Okay. Yeah. Thank you so much. You
Doctor,
understand everything?
there's only
Yes.
11 chapters, right?
Yeah. After this, one more lesson. But we need. I can't rush with the portion. You understand everything, right?
Yes, Doctor.
Okay. Only a few students. Okay, but I know who all were there. Now Munira, Iyad. Oh yeah, Aisha, Rehma. Okay. Okay, my dear students, thank you so much. Okay. Yeah.
Doctor.
Sit
Have a
there.
nice
Don't
day.
forget about this exam. Okay, don't forget about. Okay.
Inshallah.
Yeah.
See you.